Welcome back to Emerald Hill Skies. Who knows if we still remember how to work all this stuff, right? It has been weeks of Canadian wildfire smoke and high clouds and medium clouds and low clouds. And finally, along about Tuesday or Wednesday, as you know, we saw that this night was starting to shape up to be clear. You know, that green boxes on that Clear Sky app that we use to predict weather. And so, sure enough, as we came tonight to Emerald Hills, we were able to see amazing views of the night sky. Now, I don't know if our equipment is all going to line up correctly because, like I say, it's been weeks and weeks. But let's go ahead and get started. My name's Doug. Emerald Hills is a campus where I serve a nonprofit. It's on the outskirts of Louisville, Kentucky. We have a little observatory set up there. Let me see if I can find a shot of that observatory for you. It's a little Pier-Tech 2 roll-off roof observatory. And it has a 11-inch RASA scope in it that's mounted on a Pier-Tech Adjustable-Height mount. And it has an iOptron mount, pier I should say, adjustable-height pier. Has an iOptron mount on it, and that RASA11 is sitting on top. On the end of that RASA11, we have got an ASI2600MC Pro, a ZWO ASI2600. And on top of the RASA, we have this little outrigger plate that's set up with an ASI178 monochrome camera that we use for images of the night sky, just to kind of show you what the night sky is looking like. And sure enough, there's the night sky. Now, what we don't have yet is we haven't shown you pictures of the power distribution box there and the USB distribution box. At the base of the scope, there's this, what we call a rig rack set up in a little rack space waterproof box, and it has all the AC power and DC power, voltage transformers, has the device that's made by Icron that translates all the data into a stream of fiber optic cable and relays it to a companion box that's sitting here on my desk inside the prayer shelter, the prayer center and atrium where I'm sitting here tonight. And it's really awesome to be able to work inside because you don't have you know, bugs, and of course with the scope you can't really have lights on to be able to read books and all that. So we're operating about 200 feet from the observatory. And again, that observatory, it's got a nice little sidewalk now that leads to it. Looks like we need to do some landscaping there, doesn't it? But other than that, it's really a fun setup. The scope itself can be viewed live with this camera. This is at the base of that pier, and that's a live shot of the scope. So those little pinpoint lights that you see, those are actual live shots of stars up in the sky. And you can see the weights that are cantilevered off there to the left. So that's a live shot. Now, what we've got is this beautiful picture of the night sky. I'm trying to figure out where we could perhaps help you see where we are. So why don't we bring up a view of Stellarium, which is our planetarium software. And just for orientation, this is the edge of the observatory, and there's my truck, and that's where it's parked tonight. And if you can peer really closely, that's the building I'm sitting in, and right here in the corner is where my office is. It's about 200 feet to the observatory. So here the scope is aimed off in the southern sky, and look how it's aimed kind of into the Milky Way. And in fact, we're aimed pretty much square into the large Sagittarius star cloud. And in particular, part of that cloud is this large, whatever you'd call this, nebula here within a nebula, Bade's window or whatever, I think. And then we're looking at the red rectangle here is the approximation of the field of view of the RASA. It's about, I don't know, maybe, what is it, 1.5 degrees by 2.5 degrees, something like that. And right there in the middle is NG66528. And using our Deep Sky Planner software over here to the right, let me just pull that in a little bit more front and center so you can see it. This is Deep Sky Planner, what we use to be able to do our targeting. You can see we're pointed at the Secret Deep object number 79. And the Secret Deep is from this book that Stephen James O'Meara wrote. And it's called, appropriately enough, the Secret Deep. He did this list of objects that he thought were kind of overlooked. They were sort of secret and a little bit more advanced than the Messier list, a little bit harder to find. But yet they were things that really were outstanding if a person were to be able to, zoom into them. So right now we're looking at the 79th object on his list, and it is NGC6528 in Stellarium here. You can see this is a fairly rich part of the night sky. Now before I go any further, I'm just going to come over here to the stream and see if you guys have made any comments. There's Mike. How you doing, Mike? Good to have you here. And Ray, glad to have you back as well. Books, good to have you here as well. Dennis, welcome, I think, in Colorado. Tiffany from down in Florida, I think, Tiffany, or somewhere down there. Don, good to have you back as well. Stu, so good to have you back. How long is a foot? Well, I think just look down at your shoe, and that's about how long it is. I thought Americans use hamburgers or AR-15s as units of measurement. Now that is downright dastardly, Stu. Stu is speaking with us tonight from New Zealand, or I should say in his daytime from New Zealand. Don clarified whatever the length of the king's foot is. You guys have a king. Is that Trump or LeBron James? Boy, Stu, you're just stirring up all kinds of trouble tonight. The almighty dollar. It's good to have you guys back, honest. And the way this works, we read a little bit from Stephen James O'Meara's book, and then hopefully you guys who are watching online can perhaps look a little bit of these things up. And Don has just brought up a good point. The Perseid meteor shower is happening all weekend long. In fact, it's already happened. If we dial up the sky cam, I'm not sure if we actually take a look at that for a minute, if we're going to be able to see any live shots. Now you can see there in the sky cam, you can see the Milky Way, can't you? And let's see, you can kind of see a rich set of star cloud there that we're peering into, can't you? I'm not sure what else we should be able to see there. Let's see. Is this, trying to get my bearings, looking at this thing sideways. Sagittarius should be there somewhere, huh? Somewhere maybe right here. Is this Sagittarius? There went a satellite. But if we look at this long enough, we should be able to see some of the Perseids going by. But right now, let's get to this this object, NGC6528, and let's go to a live view of it. And this is it now, as soon as I go back to the screen view. This is a live view through the RASA11, and we're zoomed out so you can see the entire full field of the RASA11. And this is a 20-second exposure, but we've done about 8 minutes of those, so 25 frames stacked, an accumulation of 8 minutes. And right here in the middle, I believe, no, right here, I bet, you can see, let's do a plate solve only and make sure. But I bet this is going to be our NGC6528 right here, and I bet this is going to be our NGC6522. So what we're doing now is letting the camera use its library of stored photos and compare that library with the live view of the night sky. And through the magic of, computer wizardry, it's solving where exactly it's looking. And then what we'll do is we'll turn on deep sky annotation. And sure enough, there's 6522, and here's 6528. So I might have had them reversed, huh? 6528, or object 79, is here on top. These are a couple of bright stars, Hipparchus 88635, Hipparchus 88567, and NG 6519, a double star. But this is NGC 6528, a globular cluster there. So let's take those off. So 28 is on top. So this is 28. Now let's zoom in a little bit. And that's about 100% of the RASA's ability to work with this ASI2600MC Pro, and using its native resolution without cheating any into the digital realm. That's its full optical resolution. So you can see this is a pretty tight globular cluster. Let's open up an observation of this. And of course, we'll have to make sure that we're aimed here on August 11th. And then we'll say, looks like a tight glob in our RASA's frame, bright, concentrated, almost, what color would you say that is? Almost orangish. Now let's see what Stephen James O'Meara says about, let's see, that's 6528. Isn't that what we said, that 6528 was on top, right? You guys correct me if I'm wrong here. Deep sky image. Yeah, 6528 was on top. So let's see what Stephen James O'Meara says. This is his object 79. And he says about 6528 being seen against the galactic bulge. Both lie in it. Says it's hard to study clusters like this in the bulge because there's so many background stars. Says it spans about 28 light years, and 22 is twice that. Talks about some of the metals in it. These are metal-rich clusters, except 22 is metal poor. He says 6522 is 6,500 light years from the center. Sharp difference in visual view between the two clusters. They are different, aren't they? 6522 appears more distinct and greater brightness. That's the one down here on the bottom. Due to the fact that it's very massive. And it's this 6522 down here is one of the most compact globular clusters known. Core collapse cluster it is. Stars are being stripped away from its outer halo. And then he tells you how to find them. And he says it's a glorious sight. One dense patch. Let's back off a little bit and see if we can see this patch of darkness that he's talking about. Whoop. I wonder if this is, oh, here, look. This is the patch of darkness. Look here. See that patch of darkness there? So he's talking about they avoid that patch of darkness. It's a bleak black spot. It's Barnard 298. So it is dark matter. He says he thinks that these two clusters look like beads. Let's get this description he gives it. Beads on a snow-covered sweater. Well, that's a pretty good description, isn't it? Beads on a snow-covered sweater. 6522 is a fuzzy knot of light, just 3 arc minutes wide. And you can't see much of the halo, he says, with his 5-inch. He says a 12th magnitude sun kisses the halo toward the northeast. Yeah, you see what he's talking about there? He's talking about this maybe, or that. I think maybe this. That star right there maybe. And then he says 6528 is dim. It's only 1 arc minute wide. Fuzzy star is what it looks like in his 5-inch. He says he sees its core as being divided in 2. The halo seems to scintillate nervously with erratic flashes of dim light. It's a visual illusion owing to the multitude of stars seen projected against its face. Pretty nice descriptions. So let's just say, looks like a tight glob, almost orangish, dimmer than 6522. Let's see what you guys have said about 6528. Stu says unusually metal rich. That's something that Omir also said. Similar to 6553. Wow, you guys have written all kinds of things about this. Sagittarius. I wonder what I've got in the, oh, I don't have anything. In Bade's window, a relatively clear area near the galactic equator, discovered in 1784. Awesome. So that's 6528. Now we'll do a quick observation of 6522, and we'll say that it's brighter than 6528 in the same frame. Lots of glow, tight. You can see why he calls them part of the secret deep, because you almost lose them, don't you? In that rich cloud of the Milky Way, you can see how that, as you look with maybe a 3 or 4 inch telescope, they would look sort of like yet another glowing star in this rich star field. So pretty cool introduction again to the secret deep list. And by the way, I should ask you guys if the mic is okay. I've used our mic for several other things, and so I don't know whether you're hearing the background music. Is it too loud? Azray says, what the heck is snow? Been a while since you've seen snow out there, huh, Ray? Stu says, copying and pasting from Wikipedia. Tiffany says, Stu, thank you, you're amazing. Tiffany thinks you're pretty much a walking encyclopedia, Stu, so don't tell her otherwise. Tiffany says you're appreciated. We love it, Stu, because you give us all this background info. You guys will tell me in a minute, won't you, about our audio to see if we're doing okay on our audio. Well, let's go to the next object, which is NGC 6563. Before we do, let's go back. Let's go over here and save exactly as seen this image. That's 18 minutes now. I gotta say, that's just a beautiful set of 1,000 points of light, more than 1,000. By the way, it is so nice to have everybody back. and to know that you guys didn't give up on us. I'm telling you the honest truth that this is the first clear night since, for me, May. I did try to come once in June or July. NGC 6563 is next. And all I could see was wildfire smoke up there. And so I didn't even try to broadcast. There's a live view of the scope as it slews to the next target. Audio seems fine, Ray says. Tiff says mic and music are perfect. Well, that's amazing. Asray, not in my area. I have a 2-hour drive to see any snow. Well, that's a bummer. We could all come out and visit you otherwise, Asray, and do a field trip. Okay, so we're looking at a live view of the sky there from the little, what you might call a night vision camera that we have mounted at the bottom of the adjustable height pier, and it's basically looking straight up along the edge of the adjustable height pier. So that view of the telescope is from the south side of the pier looking straight up. So I guess east would be to the right. So you could say the telescope is now pier east, is what you'd say. And the weights are what you'd say pier west. I'm going to go ahead on the title on screen here. And I'm going to put something like this is I'm going to put this is Secret Deep 80, and it's NGC 6563, a planetary nebula in Sagittarius. Sagittarius have 1R. Anybody know? Let's go over to our planetarium software, if we can. Here we go. Well, we didn't have to travel too far, did we? Sagittarius looks to have 2 T's, 1R. 2 T's, 1R. We'll learn to spell these one way or the other. Okay, so let's look at the screen so we'll get an idea. We're still pointing at approximately the same part of the night sky, but we've dropped below Bad's window, or Bade's window, however you say that. And we're now just right off the edge of the teapot. That's a beautiful view of the teapot there. And in the sky cam, let's see if we can spot the teapot. Now that must be the spout. And then this is the bottom of the teapot, would you say? And then here's the handle of the teapot, right? Am I right? There's so many stars there. It's kind of confusing. Let's drop this a little bit. Let's bring it down to maybe 250. Make the sky a little bit darker. That's maybe a little bit too dark. Let's put it up to 300. That's 300 gain in that ASI178. Can anybody spot Sagittarius yet? Let's see. I wonder if this is Corona Australis. It's kind of like a crown, you know. I'm pretty sure this must be the Sagittarius teapot thing here. I'm pretty sure that would be the spout, do you think? And so we're looking right off the spout. This might be, maybe this is a little bit of Scorpius right here. It's a little bit of, a little bit of Scorpius, the scorpion. You can see his thing curling up. There goes a group of nice satellites that Elon has put into our frame for us. But no meteors yet, huh? Anyway, let's zero in on this and see what we're supposed to be seeing. We should be looking at the Southern Ring Nebula here in the middle of our frame. So let's go to the live view now. And wow, that's a pretty bright set of stars. So we'll do a display histogram stretch. And actually, that's not too bad, is it? There's that planetary right in the middle. So let's zoom in on him. So there is 100%. But I think with planetaries, with a RASA11, it helps to zoom in a little farther because you can see a little more of the structure of the planetary nebula. We are seeing a couple of stars inside the planetary nebula. I don't think we can bet on for sure which one of those is the middle. It might be that this star right here is the center star of the planetary nebula. You guys that are regulars on the channel, you'll remember that a planetary nebula is sort of like the outer shell that was ejected as the star began to shut down and lose its ability to do nuclear fusion. So it jettisons some of that material, and then the star has shrunk some. So now with its own gravity again, it kind of continues to illuminate. And as a result, sometimes you get multiple jettisoned material, and it causes these multiple shells sometimes. This is not a huge planetary nebula, but if you look very closely and study your screen, maybe you can make out more red here. Maybe you can make out more green in the middle. And those are just the different chemistries of the planetary nebula. The red, for instance, might be hydrogen that was jettisoned. And then the shell that we're looking at, maybe we're watching it from the top, I don't know. Maybe it has polarity, and we're looking at it through the North Pole of that planetary nebula. And sure enough, these gases ionize, and they take on a kind of gravity of their own and arrange so that we, in a sense, see poles to these planetary nebulae. And the green might be oxygen, for instance, that we're staring down almost like a barrel of gases around that central star. So it's definitely a beautiful little planetary nebula, even if it is rather small. We're at 6 minutes now of total accumulation of frames. Let's see what you guys are saying about this. Let's see. Stu says, good opportunity of new things to rise and be visible. Yep, that's true. Ray was worried about maybe Stu getting flooded out. Dennis says, haven't been able to get out for 4 weeks, been in Vegas enjoying 113-degree weather. Wow, Dennis, you'll have to tell us if you avoided the slot machines. Tiffany's talking about how hot that is, that he was toasty. Ray, good to be back in action for sure. Stu says, 85 there in the summer. Winter now, almost freezing. And Tiff says to Stu, it sounds like a perfect climate. And Stu says, 'tis lovely. Don says, spectacular for this planetary nebula. Ricky, good to have you on board as well. Good to have you back. Azray says those meteors will emanate from Cassiopeia, but I think they'll scatter through the whole sky. And Tiffany's greeting Ricky. So this planetary nebula, let's read what Stephen James O'Meara says about it. He says it's the southern ring. It's a beautiful planetary nebula, and let's see, talks about this object being a hidden treasure, but this is secret deep. He's getting his metaphors mixed up. He says he would have included it in hidden treasures, but he finished that book before he found this object. And so then he found this object cruising around Sagittarius, checking it with the Sky Atlas 2000, noticed this NGC 6563 tiny symbol, and decided to check it out. He says there is indeed carbon monoxide around the nebula. Appears fragmented, with carbon monoxide coming from discrete though unresolved clumps. Mid-August is the best time to observe it. How about that? And it's near Scorpius and Sagittarius. He's trying to help us find it. Boy, thank the Lord for electronically assisted astronomy and plate solving. We didn't have any trouble finding it. Says it's just barely visible in a 5-inch, but it's looking really fun in this 11-inch. He says a circular glow of uniform light with a hint of a central star. It's so small and condensed. He says he just barely starts to see a ring structure. And the center's not dark, but filled with misty light, less intense than the surrounding ring. So he's not seeing color in his telescope live. See, he doesn't mention anything of color that we're seeing with electronically assisted astronomy. So let's just say here that with EAA, we could easily make out bright reds around the outside hydrogen rim, and oxygen gases throughout the middle core. We could see what O'Meara called the central star, but there were several stars we figured were superimposed over that central star, so it was hard to be sure. Stu says it's 48 arc seconds. Man, that is one of the smallest objects we've ever observed. Mag 11, so pretty bright in a dense star field. That's all Stu can find. I tell you what, it really does digitally zoom in well. That's 230%, and now it's becoming mosaic-y a little bit, pixelated, but you can see those two little stars, and O'Meara probably saw that as one in his 5-inch. So probably the one off to the right here is the center core, I bet. But this is such a rich star field, it also is fun to back off, isn't it? And just take in that sight of all all of that stream of, I mean, it's just a giant lake of little glistening wave tops, you know, glistening in the moonlight or something. It's like an ocean. You're seeing all those little ocean ripples. But here in the middle is this inner tube buoy floating there in the ocean. We're observing from a drone high above. Maybe these are some floating buoys that have been set out by barges or something. But look at all those glistening waves. It's just beautiful. I love being able to take in that Milky Way star cloud. Oh, look, Stu says it's a binary star. Could that be? Were we actually seeing the binary star when we zoomed in on it, you think? Because, you know, we kept saying that we were seeing two stars. Wow, that would be fun, wouldn't it? If we observed that first and then Stu tells us that he found it. And so one of those stars wasn't superimposed. That's actually the binary star center. And that's part of what makes the gravitation of setting up that polarity that we talked about. Wow, that's fun, Stu, that you could find that. Orbital period is 2,600 days. That's quite a long year for these planets that are orbiting around this planetary nebula to put up with a 2,600-day year. Well, that's a beautiful scene. You know, in our native resolution, that's going to be a very small photo, isn't it? That planetary nebula. It's just, what did you say, Stu? Probably 48 arc seconds wide. That's like 2/3 of an arc minute wide. Whew, that's tiny. But we'll go ahead and shoot that picture and push on to the next object. We stayed on this a long time, but it's probably because we're just getting back into the run of things, huh? Let's go to this diffuse nebula, 6589. 6589. NGC 6589 is Secret Deep 81. This is NGC 6589. While that's queuing up, I just want to remind everybody, if you're watching this broadcast and if you haven't subscribed before, it's always a fun thing if you do that. What it does is probably helps with our, you know, algorithm finds, you know, so that when people are searching for things, it pushes it up in the algorithms. That's one way it helps. It doesn't cost you anything if you would like to subscribe, but if you don't like content like this, by all means, don't subscribe. We're not trying to, you know, force you into something you don't want to do. But it would be great if you felt like subscribing. This is Secret Deep 81, and it's NGC 6589. And what it is a diffuse nebula. And it's also in Sagittarius. So again, we'll look at the sky cam and see that we're still in this basic part of the sky where this Milky Way cloud is, very rich still. That's not a meteor. That's perhaps an airplane or slow satellite. Let's go over to our planetarium software, which is Stellarium. And what we'll do, using our Deep Sky Planner targeting software, in one little click, we can make it queue this object up. And let's just back up to get our perspective. Now we're up above the teapot. See the lid of the teapot? And we're up above that, still pointing south. So see this little compass point, oops, sorry. See this little compass point here south, and that's the meridian, the line that lines up with the south and north poles. If you could connect those across the top of the sky through the very tip top of the sky. And look how we're up the top, off the top of Sagittarius's teapot. and our little red rectangle is pointing just outside the Sagittarius star cloud, and this is IC1284, a hydrogen gas cloud there, and then NGC 6589 is supposedly that little interstellar matter there, and 6595 is a star cluster right here, and 6590 is a reflection nebula. Well, this is great because we're getting 2 or 3 things for the price of one here. This cluster, 6595, NGC 6595, is the cluster that's lighting up the diffuse nebula 6589 and the nebulosity of 6590. The reflection nebula of 6590. So we've got a diffuse nebula that is just gas clouds, and then a reflection nebula, the light's bouncing off of the clouds and reflecting back at us. And then notice we also have this huge IC1284, which is a hydrogen 2 region. And together with that is this giant star cloud, M24, the Sagittarius star cloud, which should be visible up in the upper left. So now let's go over here and say, yes, the mount's settled, and it'll start the plate saw. We should have let it do that while we were talking, huh? What a beautiful section of the night sky, right? I mean, it's just so rich in objects. What is this SH235 here? Is another H2 region. Just not as obvious here. But M24 up here in the top, it's the Sagittarius star cloud. We got several H2 region nebulae, and here's another H2 region, so these are side by side. While we're here, we ought to point out this patchy unnamed cloud here. How'd you like that to be your legacy? Patchy unnamed cloud. All right, let's go over to SharpCap and see what we're able to pull out here now. SharpCap is the imaging software we're using, and the first thing we do is we do a reset on the display histogram, but it's got to wait until it's completely done with our, there we go. Now we're going to reset the display histogram, and that sort of lines up much of the image to be a little bit right. And I don't think we have to reset the histogram here because I think it looks like it's already doing just fine. There's no moonlight competing with our scene. This is just beautiful black, inky black sky with these star clouds. Let's do a, boy, we don't even have to do a color matching. Okay, so up here in this corner is what we were seeing here. And you notice how our camera, where our scope is pitched over a little bit so that we're not seeing things precisely the way the planetarium software was seeing them if it were on an alt-az mount looking straight up at the sky. See, if we were on an alt-azimuth mount, then the bottom of the scope would be south, and the top of the scope would be pointed toward the zenith. And this thing would look precisely like it does in Stellarium. But we're not on an alt-azimuth mount. We are on an equatorial mount. And so you can see how our telescope is actually whopper-jawed sideways. So when we look using our live camera, the top of the sky is toward the right. And so this star cloud here, being that the top of the sky is toward the right, see how this our rectangular is kind of helping us understand that. So we're going to look for these two things here in the middle, and let's zoom in on them again. Let's use our deep sky image annotation, and 6590 is here on the left, 6589 is the one on the right. So this is object 6589. So we're in a live view now. It's as if you're looking through an eyepiece through the end of our 11-inch telescope. And you're seeing this real time. There's no delay. And this little patchy thing is the diffuse nebula called NGC 6589. It's so small, isn't it? And that is Secret Deep 81. And all Stephen James O'Meara says, this is the entire article about this nebula. It's like not even a half page. And all Stephen James O'Meara says is, oh, no, he adds a little bit more over on the next page when he writes about 6595, which is here to the left. So this is, well, now let's make sure. 6595 and 6590 are apparently the same, or overlaid. Maybe they're the same in his telescope. See, because this is the way he's looking at them. He's looking at them like this, and he says they're really overlaid. But when you zoom in, maybe we're looking at this, or this, 6589, yeah. Well, he's seeing these two in his scope. So he's seeing them like this, 6589 and 6595, 6595 and 6590. These two. So he calls this Secret Deep 82, these two objects together. 95 and 90 are both. So let's do an observation on that first. And we'll say that O'Meara named Secret Deep 82 for the cluster NGC 6595 and the reflection nebula NGC 6590. To him, it was all one object. Now let's go back over here and see if we can separate them. Yeah, we can, can't we? Easily. In our RASA's view, we can see this nebula and then this cluster. And look, there's even like a dark patch here, which will be interesting to see if he talks about. Let's see what he says. Two small but reasonably bright reflection nebulae in a maddening crowd of stars, dust, and gas. Perfect examples of how little things of interest can be overlooked because larger celestial wonders nearby steal our attention. Actually, the two nebulae lie immediately southwest of a larger H2 region. Now let's back off, and there's the H2 region coming into play. Let's see if we can brighten that up a little. Yeah. See how we're just starting to see that red cloud? So there's the red cloud that would be called IC1284. And he doesn't list that in his secret deep, but that's IC1284. So in our observation, let's say we could easily make out IC1284. Is that what it was? IC1284? Yeah. IC1284 nearby an H2 region. Dim but visible. Let's go back to the live view now. So see that H2 region, and the more we pump up these mids, the more that H2 region is going to shine. Boy, that's just really cool, isn't it? Now look at this. I wonder if (6595) and 6590. He's writing about them together. The two nebulae lie immediately southwest of the cloud, discovered photographically by Barnard in 1892. He later found it on an image he took of region 89. So it was 7 years after he took the image. He describes the discovery. Says he couldn't be certain he was seeing nebulosity. Wow, isn't it amazing that in 1890, with his scope, he was photographing this, and now with just a typical little amateur 11-inch scope, it's bright to us. He points out that Dreyer got these mixed up. He had the Lick Observatory 12-inch telescope showed that these positions were off. He strikes out 6590 as the correct position of 6595. I see. So he got rid of 6590 here. This nebula was originally also named NGC 6590, but that name was stricken. Let me see what you guys are saying about all this. This is fairly confusing to me. Folks says, remember to hit the like button too. Thank you very much, folks. So Stu says 6589 is a reflection nebula discovered in 1867, and then Barnard listed it as IC4690. NGC 6590 is right next to it. 6589 is the top blue mass. So what you're saying, Stu, is that 6589 is here, and it's got more bluish. So the gas behind this is reflecting the light, Pier-Tech, good to have you on from cloudy summer in Florida. Boy, this is our first clear night in weeks, Pier-Tech. NGC 6589, which is here, is reflecting the light of its central star, a blue type B2 sort of massive star with a magnitude of +10. Apparently some blue supergiants exhibit nebulosity due to ejected matter. And Tiff is noticing this red as being great. Mike says amateur 11-inch scope. Pier-Tech laughs. Now I'm wondering if this thing right here is a piece of dark nebula. That little black spot there appears to be dark matter or dark nebula, doesn't it? Let's go back real quick here and see if, oh look, there's that dark spot. But it's not named. Whoops, I just messed up our timing here. Let me go back here and say, there we go, fixed it. That black spot is not named, but I wonder if that is actually dark nebula. Don says mine was 13-inch, but it's Opsonian, so this one is far better. Well, that's kind of you to encourage, Don. I think EAA is what's helping make this better for us. I bet that's a piece of dark nebula, and it's just not named. See how obvious it is against that nebulosity? So that's like soot in front of the reflection behind it. So are we saying that 6595 is the patch of nebulosity? This would be a reflection nebula, is that right? 6595 is the reflection nebula, yes. So actually, Omira says Herschel is the one who discovered this. He says faint, pretty large, considerably extended, double star involved, and then Swift rediscovered it, but published it under a different name and listed it as a cluster. But Omira says no cluster exists, only the nebula's central double star. So look here, this is the double star of this nebula that's causing that to light up. So there is no cluster. So the 6595 cluster nebulosity in my list is actually just nebulosity. So I'll have to correct this when later on I'll have to correct this. 6589 is the diffuse nebula that we see here. So let's add an observation of that. NGC 6589 is off to the right in our frame of view and seems to us to be more bluish. I see whatever that cloud is, 1284. I see 1284 H2 region is nearby in the same field. Well, you can see why Omira says this is like a secret deep, because look at all the secrets he's unfolding for us here about how mixed up this all was. He says Barnard is responsible for a mistake because he called the IC by the name 4690 when it's really 1284 also. Modern star charts label that hydrogen 2 region 1284 Sometimes they call it 1283 and 1284. Though he says IC 1283 is a minute nebula around a star in IC 1284 discovered photographically by Barnard. What a mess. 6589 and 6595, together with IC 1284 and a number of other interesting smaller nebula features, are part of the LINS 291 cloud, a major molecular cloud complex in Sagittarius. So we'll call this L291. That's LYNDS. All of this together combines to make up a molecular cloud named LINS LYNDS 291. So I guess you call it L291 cloud, right? Yeah, L291. The entire cloud is embedded in a larger ionized region known as GUM78, which may be excited by the Sagittarius OB1 associations, very active star formation. So let's back off now and look at this whole region. Yeah. He says, look at this whole region of red. Let's go back over to this and back off and says, yeah, it's embedded in this entire region of a cloud. Whew. No wonder we missed this, because we're looking at M24. He says, in color photographs, IC 1284 appears red. Well, the fun thing is, we're observing it live as red. That is an eyeball. Stu says, NGC 6595 is the cluster, 6589 and 6590 are the nebulae. So what we have to do, Stu, is we have to ask, is there really a cluster here? Yeah, I think you're right, Stu. A lot of contradicting numbers and letters. I think what O'Meara is saying, if you can trust O'Meara, and we normally do, is that this double star was mistaken for a cluster, and that there never really was a cluster there. What a beautiful patch of the night sky. We spent about 19 minutes here, but that's because it's just particularly beautiful, isn't it? And it really doesn't even give credit to the M24 cloud, which is right here, which would be much bigger if we could back off and see M24 like this, see? M24 would take up more than our frame. So we took that picture. Let's while we're here, just use our stellarium, which can also be used to point. We'll hit Control 1, and that should bring up our see how our telescope just traveled over to M24 because we highlighted M24 and then we hit Control 1. And that caused the scope to slew over to it. So with the orientation of our camera, we will now see M24 across our frame, but it's sad that we don't have a way to rotate the camera. But with the RASA11, it has such a short, the 2600 combination, there's not much space to put in a camera rotator, especially one that's electronic that we could rotate from indoors. But imagine if we could rotate the camera, we could perhaps orient it and see more of this cloud, M24 cloud. But as it stands, we can't. So there is the plate solving and reconfiguring of the scope. So we're aiming right at M24. Stu says, check out this image. Which exact image should we be checking out, Stu? 6595 or what? I suppose our title on screen should probably say now M24. And you would call this what? Just a massive, what would you call M24? A massive star cloud, nebula, or something? What would you call it? Wow. That's a live shot. Look at this dark nebula in front of M24 here. That would be SH241. No. I'm afraid those dark nebulae are not named in Stellarium. But they are sure marked. They sure stand out, don't they? In our live view. I mean, you just got these thousands and thousands of points of light, and then this absolute dark island there. So I would say that's a dark patch, perhaps, and then there are a couple of stars in the foreground over the top of it. Maybe, you think? Yeah. And this is like a dark river, a nebula there. I wonder what this is. Look at that. It looks like a straight river of tiny stars making a little triangle there. I wonder if that's a named spot. Maybe that is this cluster. Let's get our orientation. So it would be, yeah, CR469. I wish we could just call up, I guess we could go to this observe next, and with this file open we could say edit, plan, add, and hunt for CR469. Couldn't find it. Couldn't find it in the Simbad list. And I couldn't find it. So we're just going to try to add it anyway. See if it'll let us. A valid object type must be selected. So we're going to call it a star cluster. Cluster. And how does it know where we are? It's a bummer. Wish there was a way it would know where we are. Anyway, we're just going to say, oh, there it picked up our location. We're going to say, this is a beautiful little triangle of a cluster. Gorgeous, tiny, lost in an ocean of stars. Let's go back to the live view now. So we're talking about this cluster here. Happy to see it has a name. It's really cool that we can make, like for us, that was a discovery. I mean, we could see that that was a cluster. We could see that was something special. And then we can go look up and realize, oh yeah, somebody else made that discovery before us. So that's pretty fun, isn't it? Well, we kind of got sidetracked there, but that's fun, isn't it? The galactic core, stars, clusters, other objects comprising M24, part of the Sagittarius Carina arms of the Milky Way galaxy. Frank Rossetti! Good to have you back, Frank. It's good to see you again, Frank. We've gone for weeks with those Canadian wildfires. Don, as you use optical aid telescope to peer out in the dark, so I'm using optical aid microscope to peer into an opal I'm cutting. That's crazy, Don. We're opposite ends of the quantum spectrum. Stu says, oh, nice, Don. Just been learning about cutting the Cullinan diamond. Tiffany, nice, Don. Opals remind me of the little galaxies. That diamond is crazy. The cut is amazing. Don't do faceting. Opals are best. Larry Fraley, good to have you aboard from Phoenix. Thanks for stopping by. You're a busy guy. Thanks for stopping by to check in on us here. Don's telling us about his white opal he's cutting. Well, this is a beautiful view of the night sky. We're just going to take a picture of this. M24. There's a lot here we could discover, but let's push on. Let's save this list that we went and added CR469. Now let's go back to our list we're supposed to be working on. The next thing we're supposed to look at is NGC 6638. Now I wonder if NGC 6638 is in the same view. Oh, it's not. So let's go back here and go to the next target of NGC 6638. And the scope will adjust a little bit. Probably it. So here's the part of the sky. We're still spending our time in this Sagittarius star cloud here. We're about 26 degrees above the horizon. So for orientation, this is where our RASA frame is now. Right there, aimed at 6638. And it's basically, if you want to find it, just look over the hood of my truck, wherever you are. Wherever you are, just look over the hood of my truck. No, for orientation, we're right here in the lid of the Sagittarius teapot. NGC 6638, and it's supposed to be a globular cluster, but they don't have any photography of it in Stellarium. I wonder if this is the same view we just saw. Did we, are we sure we changed? We didn't. We didn't slew to it, did we? Let's try this one more time. 6638. Now let's slew to it. We changed the scope cam, but we didn't actually issue the command to the scope to go ahead and do the movement. So now the scope is actually moving. And if we go to our Stellarium, we can see now that our scope field of view here is now coordinated with 6638. And now back in SharpCap, we'll say that it's settled and let it do the plate solve. But look, we can already see NGC 6638 there in the middle. So what this means is that our mount has plate solved on so many objects already tonight that we really don't need to do plate solving anymore, because what this means is our mount has created such an accurate picture of the night sky, at least this part of the night sky, that it can now find these objects without plate solving. So from now on, we could save the time, and we can navigate to things without having to do this extra step of plate solving. Because what happens is, every time the mount does a plate solve, did you see that tiny correction there? Every time the mount does a plate solve, it makes a tiny correction, and then it records that correction in its brain. So that way, when it goes to the next object, it can be that much more accurate at honing in on the next object. So that's kind of fun. NGC 6638 is a globular cluster in the constellation Sagittarius, magnitude 9.5 and arc and a diameter of just 2 arc minutes. So let's open up our observation here. 6638. NGC 6638 is mag 9.5, diameter 2 arc minutes. So fairly tiny. Now, what we'll do here is we'll do this little reset on the display histogram. And I don't know why we have to do that, but it was actually Azray, I think you were the one who told me that we have to start doing this now in SharpCap to get our stars to look correct, you know, to be correctly imaged. Now we'll bring this black level up and define the blacks to be about like that. And we don't have to bring the mids up very far, because what we're observing here is this globular cluster, which is visible to us right off the bat. And it is a beautiful one, even though it's tiny. It was discovered in 1784 by Herschel in his 18.7 inch telescope. Imagine the cost of that scope back then. Don says it was astronomical. That's crazy. Clever mount, Stu says. This is object number 83. So we're kind of going almost in order here, aren't we? 83, very small but highly condensed. It's close to a third magnitude star, right at the tip of the teapot. Hidden Gem suffers the unfortunate distinction of being in the company of two of the greatest globular clusters hunted down by amateur astronomers, M22 and M28. So he says nobody ever comes to see this one. But Herschel saw it. He talks about how it looked like it had a nucleus. He's starting to see that this is not just a nebula, it's actually a globular cluster, but he didn't know it yet. He says when it's round, it has a nucleus. And then he talks about its spectrum. There are 15 different variables identified in this, and that's surprising. It's ripe for new variables. And then he tells you how to find it. Says there are a lot of fantastic shapes and forms, looping fountains of knotty starlight, arms that are almost flamboyant, seen as if bursting forth through the cluster's dense core. The core fans out, faint arms extending radially away from the core like fractured ripples. Quite an interesting sight, he says. O'Meara helped us appreciate all the ripples and arms that make this glob unique. It is, isn't it, gang? Oh, and it's 7,800 light years away, says Stu. I'm going to write that. Says Stu. Give Stu credit. No robotics for sure. Herschel did it the hard way. He had to tell Catherine where to point the scope from atop his ladder. All right, this takes us to the next object, which is NGC 6664. So what I'm going to do this time is use our sequence that skips plate solving. This is NGC 6664, so 6664. It's supposed to be an open cluster, and we better slew to it, hadn't we? Rats. We started live stacking before the slew was done. As you can see from our screen. So see that pattern, that all that pattern is the fact that the telescope was still moving when we started plate solving. So I'll tell the software to start over on the plate solving. It's a little button down here in the lower left that you call a button called clear, and it'll start a new set of plates. I'm sorry, a new set of live stacking. I'll tell it to clear the live stack. So this particular open cluster, says Stu, is in Scutum. Open cluster in Scutum. That name has always been funny to me. Feels like we should be scooting around on a... This is NGC 6664. an open cluster and scutum. So there it is, right there in the middle. And you see we really didn't need to plate solve at all. And we didn't need to live stack either. Because you can see that concentration of stars. Yeah, good point, Don. Don says that Herschel couldn't make lovely pictures of these objects. This open cluster is kind of loose. It's object number 84. Let's see what O'Meara says about it. He called it a true hidden treasure. I cannot believe how many times I must have passed over the cluster not knowing it existed. He says that he looked through these parts of the skies a lot, and it shows how that if the mind is looking for something else, it just ignores this. He says it has a bashful appearance. He says it's really bright, and he wonders why Messier didn't see it. But the Herschels caught it. And he says maybe it's because if you're looking at M11, M26, and NGC, and the other NGC objects, you missed this one. You can't distinguish it much from the rich star field around it. 46 million years old. 4,900 light years. So 4,900 light years away, 4,600, is that what we said? 46 million. 46 million years old. Yeah, it wouldn't be 4,600. Tell you what, electronically assisted astronomy helps a lot, though, because O'Meara talks about a guy in South Africa that used his telescope to look at this, and he said all he could see is a murky field. But man, with EAA, electronically assisted astronomy, look how it resolves the entire murky field and gives us this beautifully, you know, in Spanish the word is níquido. I don't know how you say that in English, but it just means that all of these stars are like fine points of light. And it does have a lot of cool patterns. Resolves well. Mike said it, quote, looked like that bright star sneezed. Don called it a swarm of gnats. I like those. We got to write a book, guys. So you're talking about this bright star sneezed. You know why he's saying that, gang? Mike is saying that because, look, this trail of river of stars goes out at this angle, and that river goes out at that angle, and it does. It looks like it went, Achoo! I love it. All right, moving on. I guess we'll capture a picture since we're here. Again, we shouldn't have to plate solve anymore, so we'll do the next target without plate solving, and we'll say that it is NGC, whoa, yeah, NGC 6717. You know, before we slew to this, let's run this and make sure it's still that high. Yeah, 28 degrees. It's 28 degrees above the horizon. And it is a globular cluster. In Sagittarius. Looks like my glasses lens after opal cutting. So you must make a lot of opal dust. 6717. So here's 6717. So we're off the handle now of Sagittarius, still over the hood of my truck. And it looks like a very small globular cluster. I wonder if it's really globular. Which one is the globular cluster? You think it's that? It is! Look how tiny that is! This is 85 in his secret deep list. The diameter is 5 arc minutes. He says NGC 6717 is a softly glowing globular cluster in a beautiful field between the spoon and teapot asterisms in the celestial archer punctuated by 2 golden gems. Ah, these are the golden gems. That star and that star. NU1 and NU2. Has a curious history. William Herschel discovered it. 6717. Stu says also known as Palomar 9. Yep. It's a globular cluster, a member of the Palomar globular clusters. The apparent magnitude 9.28, diameter of 9.9 arc minutes, discovered by Herschel on August 7, 1784. William Herschel discovered it in 1784. He cataloged it as a faint nebula, seen through a scope 3 dim stars in a suspected nebulosity. Wow. Hats off to Herschel. So his son John reiterated it. Says it's a very small clustering knot with perhaps nebula. A doubtful object. I see 3 or 4 of the stars, but there's also nebulous appearance. Look how it's got some different colors in it. Some of them are almost greenish, aren't they? So that would suggest some oxygen, I bet. "24,000 light years away," which is really fairly close, isn't it? Tells you how to find it. It's so small. So tiny. 5 arc minutes. We could make out some greens in it together with shades of yellow. and orange. Also known as Palomar 9. It's 24,000 light years away, give or take a parsec. Herschel was the man, and Catherine was the woman. Hats off to them for discovering all this stuff, right? Pretty amazing. They had to be so careful to be able to distinguish that from that star. Next target without plate solving is NGC 6751. NGC 6751. And it's a planetary nebula in Aquila, however you spell that. (6751). Now, for reference, we're now pretty much above the teapot, besides Scutum and Aquila. That is how you spell it. The eagle. So it's off of Aquila's head. Looks like an H2 region here. Oh man, look at that. It's called the Dandelion Puffball Nebula. For good reason, right? Oh, that's one of the most beautiful nebulae we've ever seen, guys. Look at that. (6751). Do you think we actually have it in this frame? Known as the Glowing Eye Nebula, or the Dandelion Puffball Nebula, is a planetary nebula in the constellation Aquila, estimated to be 6,500 light years away. Oh boy. Well, maybe that's it right there. Is it tiny, Stu? So we're going to do our display histogram. I bet that's it right there, and it's just super tiny, I bet. Okay, we're at 181% of our RASA's optical. We're not going to be able to turn it into a puffball, but you can see the central star. If you go up to 200% digital zoom, you can make out the central star, okay. And yeah, you're starting to see a little bit of drizzling out of the center, along the radius of the center. But it's definitely over driving our RASA11 to try to make it our RASA11 in combination with this camera, the ASI2600MC Pro. We would need a longer focal length telescope to be able to zoom in on this tighter, more tightly. this planetary looked so good in the Astro art, but with our live EAA rig with a wide field, it was a mere shadow of its actual self. Boy, that central star sure, but the central star sure beams. Lots of greens in the rim. And that's it. Sure see that central star nicely, can't you? Yeah. Stu says, like all planetary nebulae was formed when a dying star threw off its outer layers of gas several thousand years ago. It's estimated to be around 0.8 light years in diameter. It's pretty big. Default. No. Next target without plate solving. This next planetary nebula is at 49 degrees altitude. So there you see a little scope movement. Not much. And it is NGC 6778. If you've joined us in the past few minutes, it would be awesome if you could subscribe if you like this kind of content. And if you do like this kind of content, it'd be awesome if you could hit the like button, the thumbs up button. It helps get the channel more into people's heads up radar when they do their searches. And of course, that's good for the channel and helps encourage everything forward. There is a website for Emerald Hill Skies, and it's probably the one you would have suspected. If you just go search, in fact, let's just dash over there real quick and we'll show you. Here we go. If you go search for emeraldhillskies.com, this is what you'll see. Videos, you know, pictures, videos about what we do in EAA. There's a EAA 101 knowledge base that you can use to learn about EAA and read about other people's rigs, learn the skills, get the equipment. And then there are video archives that show you all of the past videos we've done in the resource section. And you can always use this to contact me if you'd like. Just there at emeraldhillskies.com. We'd love to have you stop by. And, by the way, there's also a spread shop, and it's at spreadshirt.com. emerald-hills-skies.myspreadshop.com. Or you can just go to YouTube. And at YouTube, just type in, under the search box, just type in Emerald Hills, and right here in your pick list it'll show up. Emerald Hill Skies. When you go to Emerald Hill Skies, toward the top somewhere, I would hope, will be the channel for Emerald Hill Skies. And it's just @Emerald Hill Skies. And when you go there, it's basically youtube.com/@Emerald Hill Skies, all one word. And you can click Store and see all kinds of store choices. So that's fun. And what's more, if you go to any of those choices, here's a purple, a men's premium t-shirt that's available in multiple colors, including purple, with the Emerald Hill Skies logo emblazoned on the front of it. And you can buy all these shirts and hoodies and all kinds of different products with Emerald Hill Skies logo on them. And I hope you'll stop by there. That'll be fun. If you would want to do that, we hope you'll stop by. Okay, back to our live view. We're looking for a planetary nebula here, NGC 6778. Ah, look, right there it is. Now this is one of those double-poled, you know, those bifurcated, you could call it, a bifurcated planetary nebula. See how it's got two halves? And that's created when the poles are aligned down the middle of that gulf, and the two halves are actually sort of like the giant elephant ears on each side of that bifurcated pole. It's a tiny object, isn't it? For perspective, we're at, right there is 300% of the RASA's optical picture. So let's go to object 89, which is what this is. It's nicknamed the Son of M76. NGC 6778 is a small but deceivingly conspicuous planetary nebula. And he says where it appears, it's not that far from a dark nebula that Bernard called 139. Let's look at that in, so I'm going to say show chart. And what that did is queued this up. Son of M76, sure enough. But I'm not sure the dark nebula is cataloged here. I don't think it is, sadly. But a dark nebula is simply a bunch of soot and ashes, so to speak, in front of a star cluster or cloud, so the darkness shows up. So then he talks about the way NGC 6778 began to be described. Today we know NGC 6778 is a bipolar filamentary planetary nebula with a very prominent equatorial dust disk. Two opposing lobes of matter balloon through the dense torus, creating a butterfly shape. Let's go back to the live view, and you see what he means by a butterfly shape. If you use your imagination, there's the center of the butterfly, and each of these lobes is a wing. So that's a good description, a butterfly shape. I'll try to remember that. Talks about the way the lobes are ballooning outward. Just, wow, 20 to 40 arc seconds wide. So it is a great nebula, but it's next to a lot of bright things. So a lot of people, I guess, would skip over this. Two jet-like lobes differ from one another. One lobe is linear and oriented along the bipolar axis. The other presents an S shape with changing orientations. Huh. Well, I hope you guys can see the resemblance of the butterfly there. I hope it, even though it's tiny. So this planetary nebula unlike other planetary nebulae we've observed, this one looks like a butterfly. Very cool, even though it's tiny, huh? Well, I don't know if you can see or not, but that actually brings to a close all of the secret deep objects that we could observe tonight. Let's go up here under the Alt As tab of Deep Sky Planner, and you can see right now we've selected in the filter only show us objects that are above our local horizon. And let's say now ignore that. And we're basically going to ask Deep Sky Planner to show us all the objects in the secret deep list that we've not observed. You can see it finds 3 objects. One of them is currently 4 degrees below the horizon. One is 39 degrees below the horizon, and one is 50 degrees below the horizon. So these will have to wait for fall. So we'll save these new observations, and what Deep Sky Planner will help us do now is remember that we've done all those observations you see. And up here in the observing log, in the observing browser, the observation browser, it can show us all the stack of observations, 1,466 observations. Here are tonight's observations. It can show us all these, and we can scan through them all. Messier targets, Caldwell targets, Herschel targets, NGC targets that are not associated with any of the lists I just mentioned. Anyway, now we get around here to the bottom of the list so that we can now begin creating new observations. And as soon as it gets to be the fall, we can go see these other 3 objects that are left, and then we'll have all 109 objects on the secret deep list observed. Tonight, don't forget, we also were carried away at one point and went to go observe a nebulous cloud named CR469. We observed that, so we'll save that as well. It's already been saved. And that pretty much wraps up our 2 hours of observing right when we're at the end of the secret deep list. We'll now change the title of this. I think originally we thought we would go into a book called Cosmic Challenge, which is written by Phil Harrington. But we always check these other lists, like the Caldwell objects and such. We always check other lists to see, is there anything that has risen in this season that we hadn't observed last season when we were last working on this list. And sure enough, tonight we had enough new objects that had slid over into view in this season of the year, in the deep summer, so that we could make a whole 2-hour night of observing, especially since we got carried away on some of the observations. We could make a whole 2-hour night. So I'll change the title after the fact of this live stream and make it about the secret deep. And sure enough, sometime in the fall, we'll come back, pick up these last 3 objects, and that will help us to have finished the entire list of 109 secret deep objects that Stephen James O'Meara cataloged. If you are new to the channel and you just tuned in, please do hit subscribe, hit the like button. We observe whenever there are clear skies. We like to do it once a week, but it's been weeks since we had a clear night like tonight. We loved it tonight because the moon was late rising, so we got an entire inky black moonless night to observe. We loved it that all of our friends were back with us. All of you folks were writing about these objects. Doug trying to sell enough t-shirts to afford $1 million scope. A binary central star. Yes. Don says we heard about Maui. Tiff says yes, heartbreaking. Tiffany's been there. Stu pointed out the orbital period of this planetary nebula was just 3.6 hours. So that's interesting. Don went out to see some meteors. He thanked us for the live stream. Thank you for being here, Don. Ricky's going to go try to shoot the Dark Shark Nebula. Wow, that'd be awesome. Tiff says, thank you, Doug. Have a great night, everyone. Nice to see everyone. Ray says, oh, but what fun we have. And Stu says, thanks, Doug. Hope it's not too long till the next one. Take care. You are very kind, all of you. Thanks to you guys who make it a lot more fun. Astronomy is now truly a team sport. Previously, it was not. And I'd get out there with my 8-inch CPC 800 and an eyepiece, and I'd say, that smudge is supposed to be something interesting, and I just wasn't enjoying it as much. I was by myself, and I would be freezing to death out in the winter. And then we discovered electronically assisted astronomy, as many of you have. And now we can operate without the bugs, without the dew, without the cold in the winter, without the sweat in the summer. And what's more, we get to talk to all of you guys and read books about these objects as we go. So what I'm going to do now is close down the live stream, close down inside, make sure the building's all shut down, turn on the burglar alarm, and then walk out to the observatory. Takes about 5 minutes to shut things down, lower the pier, roll the roof across, and say goodnight, and we'll hope to see you next time. So that's it for tonight, gang. Thanks again for being part of this. Do subscribe, and if you like this kind of content, I do hope you'll click that thumbs up button, and that'll help people find us. We'll hope to see you next time. God bless, and thanks to God for creating all these great objects, very interesting objects tonight. Thanks for the way He made these so we could enjoy them together. And thanks again to you guys who are on the live stream. Good night all, as Ray says. And good night from NBC. Oh wait, that's different. God bless us, everyone. See you guys soon. Good night.